Okay, so now we will be dealing with advanced level questions starting from question number 14. We're going to skip question number 15. It's a bit more complicated than it should be. Then we're going to do question number 16, 17. That's it. Okay, 3 questions that we need to do in advanced level right now. Question number 14. Basically, the shape isn't given, so you have to imagine it. First of all, basically, we read this as a trough. Trough, okay, T-R-O-U-G-H, trough. It looks like this. It's like this shape. I mean, how am I supposed to draw this? Well, I mean, no, forget about it. Yeah. Imagine there's a space inside this, right? You should go search it on the internet what this thing is, okay? There's water or food you can put in it, and then animals eat from it, okay? That's basically what a trough is. For us, just imagine it as an open rectangular box, a long one, okay? A really long one. As you can see, long. It's 1.85 meters long. That's the length. The length is given to us. Then wide, breadth is given to us, which is 45 centimeter, and then 28 centimeter. Okay, height is given to us as DPU. So height is given to us, which is centimeters, right? Breadth is given to us, which is centimeters, and length is given to us, which is in meters. So I told you, make sure that length, breadth, height, all of them are in the same units, right? So what are we going to do? We're going to convert the length into centimeters. Why are we converting length into centimeters? Why not convert breadth and height into meters? It's because the length is the only one that is in decimals, and dealing with decimals can be harder. Then that's why we're just going to convert the decimals into so we're going to multiply 100 here, and that's how we're going to convert 1.85 into 185. Okay, so yeah, we can find the volume of this trough, right? This is all externally, right? If the trough is made of wood 2.5 centimeter thick, find the volume of wood used to make this trough. Give your answers in meter cube. Exactly the same thing we've done before right here in this question. It's exactly the same one, and that's why we've spent so much time understanding that question. It's because both of them are basically the same thing. Okay, so if you have trouble understanding this question, go look at question number 8 again. You can then understand it properly. First of all, let's imagine that this thing again. Okay, take a look at this container, right? It's the rectangular open box, just like mentioned in the question, but this one isn't as long as the one that is mentioned in the question, but it works, right? We just need to understand the concept. It's exactly the same as what we did in the chapter question number 8. The only difference is that in question number 8, they gave us the internal dimensions, the dimensions of the empty space inside. That's what was given in the question. We didn't know what was the outer cuboid's dimensions in the question number 8. In this question, they have mentioned externally. Externally means we know the outer dimensions, but we don't know the inner dimensions. So in that question, if you recall correctly, the length that was given to us, we added the thickness 2 times with it. The breadth that was given to us, we added the thickness 2 times with it, and the height that was given to us, we added the thickness 1 time with it, right? Because it's an open-ended, right? That's what we did in question number 8. In this question, since the external one is given, we're going to do subtraction. So the length that we have, okay, so the external one is given, so to find the internal one, the length that we have, we're going to subtract the thickness 2 times, and then the breadth that is given to us, we're going to subtract the thickness 2 times, and the height that is given to us, we're going to subtract the thickness 1 time. Okay, why are we subtracting? Again, it's because in this question we don't have the outer we don't have the inner one, we have the outer one. In the previous question, question number 8, we were given the inner one. Okay, let's try to understand this once more time, so that even if you don't understand question number 8, you will be able to do it. Okay, first of all, it's an open rectangular box, just like mentioned in the question. It's an open rectangular box. Question says it is 1.85 meters long. It is 1.85 meters long. Question says it is 45 meters wide. So you can see this is 45 centimeters. Yeah, it is 45 centimeters wide, and the length is also given. Basically, it is this much deep. Okay, so it is 85 centimeters deep externally. This word is really important here. 85 centimeters deep externally. That means this length here, this height, it's externally, right? That is what is 28 centimeters. That's what 28 centimeter is. External one, not the internal one. The internal one is going to be different from the external because we have thickness here, right? So the internal height is going to be about this much, right? About this much. And then this is the thickness. but the external one is given. So the whole thing is given to us in this question right now, which is 28. Okay, first of all, the dimensions are given. It's a what are we going to do? First, we're going to find the external volume of the trough. Okay, so it's 1.85 multiplied by 45 multiplied by 28. Since this is meters, we're going to convert the meters into centimeters. So 1.85 multiplied by 100 will give us 185 centimeters. We're going to multiply them all, and we're going to get the volume of trough, external volume of trough in cubic centimeters. Okay, cubic centimeters, that's basically the volume of the external volume of the trough. You can say the outer cuboid. Then we need to find the internal volume. Take a look at this again. Outer length, let's just say this was the outer length. This complete thing from here to here is the outer length, right? Then this is the inner length. It's much less than the outer length, right? Inner length is much less than the outer length because of this thickness. So this is given to us. We need to find this. What are we going to do? We're going to remove the thickness from the given length. This thickness is in the question. It tells us this thickness is what? It's 2.5 centimeters. Question tells us this thickness is 2.5 centimeters. So this complete length is what? It's 185. So 185 minus 2.5 minus 2.5 minus 2.5 minus 2.5 basically means that you're subtracting 5 from it. So your answer is going to be 180. So this whole length is what? It's 180. It's 180 what? 180 centimeters. And this part of it is what? This whole length is 185 and this part of it is 180 centimeters. Then again, when you go to the breadth is what? This whole thing is what? This whole thing is 45. 45 minus 2.5 minus 2.5 is basically 40. So this length is going to be what? 40. This whole is what? 45. This part of it is going to be 40. That's the internal dimensions. We're finding the internal dimensions so we can find the internal volume of the trough, the space inside the trough, the empty space inside the trough, not the filled one from the material, the empty with air, right? So we want to find the internal volume. First find the internal length, which is again given length minus 2.5 minus 2.5, which will be 180, right? So B is going to be 45 minus 2.5 minus 2.5. Basically, you're subtracting 5 here as well. So 40. And height is going to be minus 2.5, not again minus 2.5. Okay, only one time you're going to subtract 2.5. Why? Because it is an open end. There is no thickness here. It's open-ended, but there is thickness here. As you can see, it has a thickness here. From this part to this part, it has at least this much thickness. What is that this much thickness? It's 2.5. So we're going to subtract that 2.5 from the height. This complete height is given to us. Which is 28. And we're going to subtract 2.5 from it. So we're going to be left with 25.5 centimeters, right? So we have found the internal dimensions. What are we going to do? We're going to multiply them to find the internal volume. We found the external volume. Now we're going to find the internal volume of the trough. And then we're going to subtract the internal from the external. That will be left with the wood that is used to make the trough. Okay, exactly. The rest of it is pretty much very much similar to what we did in question number 8. As long as you understand question number 8, then you understand this question as well. If you understand this question, then you understand question number 8 as well. Okay, so the answer that we got was in cubic centimeters, right? After we subtracted the internal volume from the external volume, we got the answer in cubic centimeters because all the calculations that we did were in cubic centimeters or centimeters, right? But the question tells us to give the answer in cubic meters. So we're going to convert our answer from cubic centimeters to cubic meters. What are we going to do? We're going to divide it by 1,000,000. So the answer that we have divided by 1,000,000, that means you're going to jump 6 times and then you got your answer. That's basically it for question number 14. Okay. Yeah. Then we have question number 15, which we're going to skip. We're going to go to question number 16. Question number 16, again, start by understanding the question. It's pretty simple. We have a cuboid of length 12 centimeter and breadth 9 centimeter. It has a total surface area of 426 centimeter cubic square centimeter, right? Okay, so it's a cuboid. Length is given, breadth is given, height is missing in the question. We know the total surface area and we know the volume. No, we don't know the volume. Okay, we need to find the volume. Okay, first we need to find the height and then we need to find the volume. Up until now, we have been using the formula of volume, this formula, to find either one of them, right? If any one of them is missing, so we're going to find it by using this formula. But in this question, volume is missing. So what are we going to do? We're going to have to use the formula of total surface area. Total surface area of cuboid is equal to 2 multiplied by 2. In bracket, we have length multiplied by breadth plus length multiplied by height plus breadth multiplied by height. Just leave the h as they are because they're going to be our variables and put the values of other variables, right? So we know what total surface area is equal to. It's equal to 426. So we're just going to put its value here. 2 multiplied by, we know what length is and we know what breadth is, so we're going to multiply them. Length again, put the value of length. Breadth, put the value of breadth. All of them are in the same unit, so it's perfectly fine. You don't have to change anything. Then what you're going to do, you're just going to proceed with the multiplication of constants. You have a variable term and a variable term. They're going to be added to each other. 12h plus 9h, you're going to get 21h. We have a constant term. Okay, so now I can proceed with the multiplication here. Okay, I can multiply 2 with this number, but then I will have a bigger number and it'll be harder to deal with. So what did I do instead? I just simply divided 2 on both sides. If I divide 2 on both sides, these two will cancel each other out, and 426 divided by 2 will give me 213. So 213 is basically equal to what is inside the bracket, okay, which is 108 plus 21h. Now think about it. What do we need to do? We just need to subtract 108 from both sides of the equations. We will get the constants here on one side and the variable on the other. Now deal with them. You will get 105 is equal to 21h. Now you just simply need to divide, like basically right after that, right? So we basically have to now divide 21 on both sides of the equations. You do that and you'll get a value of h, which is equal to 5 centimeters, okay? Once you know the value of h, we already knew the value of length and breadth, right? We knew the length was 12, breadth was 9. Now we know h, which is 5. So what do we need to do? Just put them in the formula of volume, and you will get what the volume is. And they are not even asking us to convert volume or anything else. So this is basically just your answer. It was just that simple. Question number 17. It's pretty easy, okay? All the questions in advanced level were much more easier than intermediate. So I don't know what their criteria for advanced level is, but this one very easy. They have given you few diagrams here, like 1, 2, 3. They have 3 diagrams. This is a room. Imagine this is a room, okay? It has a volume, it's a room, it's a long room. This one is a cubic room, and this one is like a pizza box kind of room, like what the hell. Anyways, we have these 3 rooms, each of them, here the area is given to you. Okay, first of all, focus on the question. Let me just zoom in here on the question. Yep, that's enough. Okay. Now focus here. Question says that PQRS is the floor. In this cubes, this one is the bottom face, okay? This one is the bottom face, that's the floor. PQRS, that's the bottom face. This one is again the bottom face, this one is again the bottom face. All the bottom faces are what? Floor. They are the floors. Okay, so dimensions are all given to us. Length is given, breadth is given, height is given, length is given, breadth is given, height is given, length is given, breadth is given, and height is given. All the things are required are given to us already, right? So what do we need to do? First, we need to find the floor area, not the total surface area. They're asking us only the floor area. What is the floor? Floor is just a square face, the bottom square face. And you know what the formula of area of a square is, right? Length multiplied by breadth. So all that you need to do is to multiply the length with breadth, multiply the length with breadth, multiply the length with breadth. So I'm going to go step by step. First of all, part number 1 of question number 17, right? Room A. We need to find the floor area. We're going to do length multiplied by breadth. Length is given to us, which is 26, multiplied by breadth, which is 1. So 26 multiplied by 1 is basically, this is the floor area. Remember this, okay? Circle it down. Remember this. This is the floor area of room number 1. Volume, all the dimensions are given to you, 26, 1, and 3. Just multiply all of them. You will get the volume in the same unit, okay? This, all the units we have here is in meters, right? All the dimensions are in meters, so it's perfectly fine. Just, you don't even need to do any conversion here. They do the same for room B. Floor area is length multiplied by breadth. Length is given 5, and again 5 breadth, so 5 multiplied by 5. You're going to get the floor area, remember this. Then we have the volume, 5 multiplied by 5 multiplied by 5, 125. You get the volume. Do the same for room C. Again, we have 6 and we have 6, so length multiplied by breadth is 6 multiplied by 6, which is 36. And then volume is 6 multiplied by 6 multiplied by 1.8. So do this multiplication, you will get 64.8. Now this was part 1 of question number 17. Very easy. Question number 17 part 2 says which room feels the most spacious? Does the larger floor area or a greater volume necessarily makes a room feel more spacious? Explain your answer. So basically, take a look at them. I'm just going to focus, yeah, here. Room A, let me just zoom back. Okay, now look at room A. Room A has 26, floor area and volume is 78. Which one of the rooms has the largest? Which one of the rooms has the largest floor area? Room C. Room C has the largest floor area. But if you just take a look at room C, you can feel how cramped you would be in this place, right? If I was to be in this room, the floor, my toes will be on the, my feet will be on the ground, and my head will be on the outside the roof, right? So it's just so small. Okay, so That's the floor area. Just comparing them, the largest floor area is with room C, and the largest volume that you see is with room B. Room B has the largest volume. So basically, the one that will feel the most, okay, this is not about which is the most spacious. If it was about which is the most spacious, then obviously there would have been no other answer than B, because if they're asking us about what is the most spacious one, then that's basically asking us which one has the most volume. So room B has obviously the most volume. That's why room B would be the answer. That room B will feel the most. Room B is the most spacious one, but room B will also feel the most spacious one. Why? Because feeling depends upon how you perceive all the dimensions. Okay, so for you to feel that room B is the most spacious, it has to have all the dimensions equally distributed properly, right? So cubic shapes obviously will feel more spacious than all the other shapes that are cuboids, right? Cubic shape will obviously feel more spacious. So the second part of this question, you're going to answer it like no, because the room feels more spacious depending upon all the dimensions being equally measured. In room B, we have 5, 5, and 5, while in room A, the breadth is only 1, so it will feel cramped due to that. And in room C, we have height, which is only 1.8. It will feel cramped because of that. But in room 5, all of them are equally spread out far, and they have a good enough space in them. That's why room B will feel the most spacious. And yeah, if the volume is more, that does mean that it's more spacious, and the dimensions are supposed to be similar to one another too. For example, length, breadth, and height should be similar to one another, if not exactly equal, for it to feel spacious. Okay, that's basically it. That was it. Question number 17. It was just that simple. It wasn't that difficult at all. So go through these questions again, especially question number 14 and 8. They were a bit more conceptual, so you need to revise them and try solving them by yourself as well. Okay, that's it for now.